Okay, so this question wants us to find V of t. So if the switch opens at t equals to 0, at time equals to 0, the switch opens. Find V of t, that is the voltage in the circuit, at t greater or equals to 0. This basically means find V of t after the switch has been opened. When the switch has been opened, okay, we'll draw it. So let's tackle it one by one. So V of t at t greater or equals to 0 because V naught e raised power minus t over tau. This V naught is actually the initial voltage that the capacitor will have. You see, when you disconnect the switch, this entire circuit goes. Sorry, this entire circuit goes. And now the capacitor, because when the DC was the battery was connected, the capacitor was charging up. After you disconnect the battery, the capacitor will not be the one to act as the charge for the circuit, will not be the one to act as the battery source for the circuit. So that V naught, that's initial voltage in the circuit, is determined by what is in the capacitor in that moment. So you may see them writing VC here as well. So it's correct. So the first one I'd like to find is tau. Tau is equals to Req times C. In this case, Req is always found after the switch has been opened. You don't find it before. So when you open this switch, this entire circuit becomes useless because if current comes here, it just hangs at this point. It's not able to go to this point. So that entire circuit becomes useless. Current can't flow there again. So Req in this case will simply be these two resistors which are in parallel with each other. 12 in parallel to 4 is equals to what? 3 ohms. Then 3 ohms times 1 over 6 farads, which is equal to 0.5 second. Now you need to find V naught. I remember what I said V naught is. V naught is what? The initial voltage in the capacitor, because this V of t is the voltage in the circuit after the switch has been removed. And after the switch has been removed, who now acts as the power source for the entire circuit? The capacitor. So that initial voltage in the capacitor, that initial voltage in the circuit after the battery has been disconnected is given by the capacitor. I hope you understand that. So we need to find this. In order to find this, in order to find, okay, what was the voltage in the capacitor before the battery was disconnected? Let us connect the battery and find out. So we're going to connect it here. So we're going to close the switch at this position. Now, a capacitor acts as an open circuit when it's connected to a DC battery. So this is actually going to be an open circuit with just plus V. You can write C if you want it, just to denote. But I advise you to be more accurate in your exams. So now what we want to find is this particular voltage source here, right? As I looked at this, I saw that voltage in parallel circuits is the same. So the voltage here, same thing as the voltage here, same thing as the voltage here. So I found it safe to actually just combine these two circuits, fully knowing that VC is the same VC that is here, the same VC that is here, because they are all in parallel. So if you were to combine the circuits, it will become 24 volts, and this will become 6 ohms. This is 3 ohms. We already combined it before. You can see it here. Now to simply find VC, that is the voltage across this area, is what VC is going to be equal to what? Against volt VDR, voltage divider rule, because voltage drop here, voltage drop here is a voltage dividing circuit. 3 over 3 plus 6 times 24. And in this case, what's that? 8 volts. So therefore, we have found VC. Now we can plug it back into the equation, right? V of t is equals to 8 e raised power minus t over what? 0.5. This can become 8 e raised power minus t minus 2t, because 0.5, 1 over 0.5 is equals to 2. Find WC 0, that is the initial energy stored in the capacitor. It's simply going to be half times the capacitor times the initial voltage that the capacitor was holding after the switch was disconnected. square. So it's going to half times 1 over 6 times, in this case V, we got it as 8 volts. Yeah, so it's 8 square. It's just going to be equal to 5.33 joules. This is actually the final answer. I hope you really understood this. Thank you for listening.